Hey everyone, welcome back to our AI series. Today we're stepping into one of the most exciting parts of artificial intelligence, understanding what AI really is and how something called intelligent agents make it all work. If you've ever wondered how self-driving cars know when to stop or how your voice assistant understands you, then stick around, because by the end of this video, you'll understand the brains behind these systems in a way that even your non-techie friend could get. Let's start with a question. How would you define artificial intelligence? Well, AI is basically about building machines or systems that can think and act intelligently, sometimes like humans, sometimes even better than humans in specific tasks. We can look at AI from 4 different perspectives. Think like humans. Try to copy how we think, reason, and solve problems. This often overlaps with cognitive science. Act like humans. Replicate human behavior, like robots walking, talking, or playing games like a human. Think rationally. Follow logical reasoning to always come to the correct conclusion. Act rationally. Choose the best possible action to get the best outcome, even if it's not how a human would do it. Example. If you ask Google Maps for directions, it doesn't try to think like you. It acts rationally by calculating the shortest or fastest route based on data. AI isn't just theory, it's everywhere. Some cool applications of AI today: self-driving cars, navigate roads, avoid obstacles, follow traffic rules, speech recognition, Siri, Alexa, or Google Assistant responding to voice commands. Space missions. NASA uses AI for planning, scheduling, and adapting to unexpected events. Game playing. AI beating humans in chess or Go. Spam detection. Keeping unwanted emails out of your inbox. Robotics. From cleaning robots to ones that handle dangerous materials. Machine translation. Google. Translate, breaking language barriers instantly. Now here's where things get interesting. Almost every AI system you know runs on the concept of an agent. An agent is anything that perceives its environment using sensors, acts on that environment using actuators. Example, a robot vacuum cleaner sees dirt, sensor, decides what to do, processing, and moves, cleans, actuator. Some important terms here: percept, what the agent senses right now. Percept sequence, everything the agent has sensed so far. Agent function, the brain logic that maps percepts to actions. A rational agent always does the right thing, meaning it chooses the action that maximizes performance based on a performance measure, what it already knows, the actions it can take, and what it has sensed so far. Example, a taxi driving AI's performance measure might include safety, speed, comfort, following traffic laws, fuel efficiency. An agent isn't truly smart if it can't adapt. Low autonomy. A simple clock follows the same rules, no learning. High autonomy. A self-driving car that gets better with experience. Learning allows agents to improve over time based on feedback from their environment. When designing an agent, you have to know what kind of environment it's in. Fully observable versus partially observable. Chess fully versus taxi driving partial. Single agent versus multi-agent. Chess is single agent. Traffic is multi-agent. Deterministic versus stochastic. Chess deterministic. Taxi driving stochastic. Episodic versus sequential. Quality control checks. Episodic versus chess sequential. Discrete versus continuous. Chess discrete moves versus driving continuous. Known versus unknown. Known rules versus unpredictable outcomes. The hardest environment? Partially observable plus multi-agent plus stochastic plus sequential plus dynamic plus continuous plus unknown. Real-world driving. We have 4 main types of AI agents. Simple reflex agents react only to the current percept. Model-based reflex agents keep track of the world's state to make better decisions. Goal-based agents plan actions to achieve a specific goal. Utility-based agents choose the best among many goal-achieving options by maximizing happiness. Utility. A learning agent has Performance element decides what to do. Learning element improves over time. Critic gives feedback. Problem generator tries new things to learn more. So today you learned the 4 perspectives of AI, real-world applications, what intelligent agents are and how they work, what makes an agent rational, types of environments and agents. In the next lesson, we're going to see how these agents actually solve problems, diving into AI problem-solving strategies and algorithms that power things like pathfinding in maps, puzzle solving, and more. If this video helped you understand AI better, give it a like, share it with your friends, and don't forget to subscribe so you don't miss the next episode. Thanks for watching, and see you in the next one.